In a circuit, three-phase power may be delivered to a DC drive's power bridge. This power bridge rectifies the AC power for use by the DC motor. At the same time that the SCRs rectify the AC voltage, they control the amount of voltage applied to the armature, thus regulating its speed. This control is provided by an electronic control board which controls the firing of the SCRs. If a problem is suspected with the drive, in this case one which uses a so-called 6-pulse bridge, the first thing to do is to check for proper operation of the SCRs, making sure they are firing and providing power to the motor. To do this, you can place an oscilloscope across the A1 and A2 terminals of the motor or from the terminal coming from the power bridge. You should observe this type of curve, where all 6 SCR curves should be present within a 16.66 millisecond range, which equates to 1 pulse for each SCR on each half cycle of the 3 phases. Make sure the scope is set for at least a 16.66 millisecond scale. All 6 pulses must be present. If not, one of the SCRs is not firing because of a faulty component. If 2 of the same phases are not firing, it could be due to a loss of phase. This results in erratic motor movements and slower speed. Additionally, the motor will not have a smooth sound, and it will be reflected in its performance. If you are testing or measuring voltages in the drive system, please be extremely cautious because of the high voltages present in large horsepower motor circuits. Also, be aware that the DC motor control board is isolated from the motor power circuit, and the grounds should never be connected to equipment frame or to the AC ground. This will cause extreme damage to the drive control circuitry. Another signal that is good to check and make sure is present is the feedback in this example from the tachogenerator. This tachogenerator provides a DC voltage proportional to the motor RPMs for use by the drive. In the scope, you should see a smooth DC signal providing feedback to the electronic control board, and that there are not large spikes in the system induced by electrical noise.